Okay. Stoichiometry is just a fancy word for what?
Yeah.
Train tracks, aka unit cancellation.
Yeah.
All you're doing is going from one unit to another. So, also, for mole, a mole is 6.23 times 10 to the 23rd particles of a substance. So you need to remember, I really didn't know that he had 6.22, so I'll be consistent. You have to have this memorized. That is Avogadro's number.
Hey, Mr. Wilson.
Yes.
Isn't it 6.023?
Yeah, sorry. 6.022 times 10 to the 23rd.
Do you write music? That's the mole.
Huh? I'm about to do an example of it.
Eric Murphy, please report to the main office. Eric Murphy to the main office.
It's right here. ABO, Gatto's number, is 6.23 times 10 to the 23rd. All you do when I ask you how many particles a mole is, the periodic table is how many grams per mole, right? So let's say I had 2 grams of oxygen. 2 grams, 2.0 times of oxygen, of O2, because oxygen can't be by itself, because it's diabiotic. So, write down 2.0. When doing train tracks, always just start with what you know. It's given to you, 2.0 grams, and I need moles of it. So how many moles? There's 1 mole of oxygen, 1 mole of O2. I just come to the periodic table, and 1 mole of O2 equals, O2 is 16 plus 16. So 32 grams of O2. So 2 divided by 32, someone be my calculator.
116.
116? Which is? Decimal? 0.00. 0.00662. And now I'm left with moles. So all I have to do, Avogadro's number is particles per mole. Here my grams cancel, grams cancel. Now here, there's 6.022 times 10 to the 23rd particles for every 1 mole. So now all I do is take this number times 6.022 times 10 to the 23rd, which is oh. As Kenny's doing this, what's a limiting reagent? The limiting reagent is the one that limits the reaction. It's like a stop sign. The limiting reagent is the stop sign. You stop.
Hey, Mr. Wilson. My battery died.
Does someone have a calculator? .062 particles.
Okay. You get 3.73 times 10 to the. Okay, man.
Times 10 to the what?
I didn't do it right, Mr. Wilson. Wait, is it really fun?
So that equals 3.73 times 10 to the 22nd. Basically, this is how many particles you have. So you can go from grams to moles to particles. That little cheat sheet I gave you, it showed you which route to go. So, who's calling me? Yeah. Good. No. Okay, that's fine. Thank you so much. Okay. And now we all know that the molar mass is on the periodic table. And how you calculate molar mass is if you're given one. If you want to know the mass of, say, iron, you just look at the periodic table. But what if I want to look at the mass of copper nitrate? See, that will go CuNO3 2. How would I calculate the molecular mass of that? I would go to the periodic table, and I would go 63.54 plus, this 2 refers to both the nitrogen and the oxygen. So you have to take this 2 times your subscript, which is 2 times 1, which is 2. So nitrogen, 14 times 2 is 28. Plus oxygen times 6, because 2 times 3 is 6. So it's 16 times 6, which equals 96. And the whole thing equals what, Kenny?
Oh, 1,870.
4, 5, 17, 7, 9, 187.54.
That's what it is?
No, you said 1,000.
I'm on
So, next, we have the molar mass. You calculate it by just adding everything up. The molar mass and formula mass, it is just changing nomenclature. It is the same thing, but we are just changing it from one form to another form. Like, for instance, tomato and tomato, right? It's the same thing, but just different pronunciation. Like soda and pop. It's just a different word for it. Soda, pop, Coke, all the same thing, but
Potato, potato.
and that's what this means. They're the same thing. Now we know in an equation what are these over here?
The
Reactants and these?
the products,
Products. And what's this sign?
the yield.
The yield sign.